Have you ever looked up at the night sky and felt a sense of awe? A vast, beautiful, yet sometimes terrifying expanse. We all know the story of the dinosaurs, wiped out by a colossal asteroid 66 million years ago. It's a spectacular, Hollywood-worthy tale of cosmic destruction. But what if I told you that was just one chapter in a much longer, much more violent story? What if our planet's history is littered with cosmic collisions that have shaped life and death in ways we're only just beginning to understand? Today, we're going on a journey back in time, billions of years, to uncover Earth's hidden extinction events. These aren't the stories you learned in school. These are cosmic mysteries, buried deep within our planet's crust, waiting to be revealed. We'll explore craters larger than cities, evidence of impacts that dwarfed the dinosaur killer, and ask the chilling question, could it happen again? To start, let's go back. Way back to about 252 million years ago, the end of the Permian period. Life on Earth was on the brink of total annihilation. Scientists call it the Great Dying. Over 90% of all marine species and 70% of terrestrial life vanished. For decades, the prime suspect was massive volcanic activity in what is now Siberia. A planet choked by its own gases, but recent discoveries have pointed a finger towards the sky. Deep in the ice of Antarctica, scientists have found meteorite fragments, specifically from the Wilkesland region. These fragments date precisely to the time of the Great Dying. Even more intriguing, beneath the ice sheet, gravity and radar surveys have revealed a massive, circular structure, a suspected impact crater over 300 miles wide. That's more than double the size of the Chicxulub crater that doomed the dinosaurs. Imagine the scene: an asteroid or comet, possibly 30 miles across, screaming through the atmosphere. The impact would have been unimaginable, triggering earthquakes that shook the entire planet and tsunamis that washed over continents. The blast would have vaporized rock, sending a plume of superheated dust and debris high into the atmosphere, blocking out the sun for years, even decades. This impact winter would have been catastrophic. But it gets worse. The impact likely punched through the Earth's crust, triggering the very volcanic eruptions in Siberia that were once thought to be the sole cause. It wasn't one killer. It was a 1-2 punch from space and from within our own planet, a perfect storm for extinction. This idea of a double whammy isn't unique. Let's rewind even further, to the Ordovician period, around 443 million years ago. This was a time when complex life was just beginning to flourish in the oceans. Then, suddenly, about 85% of marine species were wiped out in one of the planet's first major extinction events. For a long time, the cause was a complete mystery, often blamed on a global ice age. But where did the ice age come from? The answer might be found in a Swedish quarry. There, scientists discovered a layer of fossilized meteorites, all from the same time period. It turns out that around 470 million years ago, a massive asteroid in the belt between Mars and Jupiter shattered in a colossal collision. The solar system was suddenly flooded with debris. For millions of years, Earth was subjected to a meteor shower of epic proportions, with impact rates 100 times higher than today. While there wasn't one single, giant impactor like the one in the Great Dying, this was death by 1,000 cuts. Each impact, big or small, threw dust into the atmosphere. Over time, this constant bombardment created a persistent veil of dust in the stratosphere, partially blocking sunlight. This didn't cause a sudden, dark winter, but a slow, creeping chill. Global temperatures dropped, ice caps grew, and sea levels fell dramatically. The shallow marine environments, where most life existed, were left high and dry. The Ordovician extinction wasn't a quick catastrophe. It was a slow grinding decline, orchestrated by the dusty fallout from a cosmic fender bender millions of miles away. These events challenge our very understanding of evolution. We often think of life evolving through gradual competition, survival of the fittest, but these cosmic collisions introduce an element of pure, random chance. It doesn't matter how well adapted you are if a rock the size of a mountain falls on your head. These impacts reset the evolutionary clock. They wipe the slate clean, clearing out dominant species and giving new, previously marginalized life forms a chance to thrive. Without the dinosaur-killing asteroid, mammals, our ancestors, might never have had the opportunity to emerge from the shadows. Extinction, in a strange way, is a powerful engine of creation. So, we've seen a giant impact, possibly triggering volcanic fury in a prolonged meteor shower, causing a deadly ice age. But the list of cosmic suspects doesn't end there. There are other mass extinctions, like the one at the end of the Triassic, about 201 million years ago. While evidence is still being gathered, several large impact craters date to around this time, including the Manicouagan crater in Canada, one of the largest visible craters on Earth. Was this another piece of the puzzle? A contributing factor to yet another global catastrophe? The terrifying truth is that our planet is a moving target in a cosmic shooting gallery. The craters we see on the Moon, which has no atmosphere or geology to erase them, tell the true story. The Earth has been hit just as often, if not more, due to our larger size and gravity. Most of the evidence has been erased by time, buried under rock, subducted into the mantle, or irradiated Hawaii. We are living on a planet with a hidden, violent past. This brings us to the inevitable question. Could it happen again? The answer is a definitive yes. It's not a matter of if, but when. The good news is, we're not the dinosaurs. We have telescopes, we have astronomers, and we have space agencies like NASA and ESA. Organizations around the world are dedicated to planetary defense. They scan the skies every single night, cataloging near-Earth objects and calculating their projects, like the DART mission, which successfully altered the course of an asteroid in 2022, have proven that we have the technology to defend ourselves. We are no longer helpless spectators. For the first time in the 4.5 billion year history of our planet, one species, us, has the ability to look up, see the danger coming, and actually do something about it. The story of Earth's hidden extinctions is a humbling one. It reminds us of our precarious place in the cosmos. It shows us that the history of life is punctuated by random, catastrophic events from space. But it's also a story of incredible resilience. Life has always found a way. After every cataclysm, new forms emerge, more diverse and complex than before. And now, we are part of that story, not just as potential victims, but as guardians. The silent, pockmarked history of our planet serves as a powerful warning, but also as a call to action, to continue exploring, to keep watching the skies, and to protect this beautiful, fragile blue we call home. Thank you so much for joining me on this deep dive into our planet's explosive past. If you found this journey as fascinating as I did, please hit that like button and subscribe for more adventures into the mysteries of science and space. Let me know in the comments which hidden extinction event you find most mind-blowing. Stay curious, and I'll see you in the next video.